everyone, I am Sulistinayah putri. I am from International Program on Science Education. Now, I would like to explain about sound. So, we are gonna learn about what is the sound itself, the characteristic, grouping of sound, and properties of sound. So, by this learning, we are able to identify why and how the sound produce different type of sound. Let's get started. Now, please close your eyes for a minute. And what are something that you can hear? Now, maybe something that you can hear when you close your eyes, maybe people talking, and then music playing, or cars going by. Yeah, there are many more sounds you might be able to hear. And then, how are you able to hear the thing? Yeah, so ear give us our sense of hearing, and the vibration go into your eyes and vibrate something, and it's called eardrum. So how are you able to make sound? Nah, we can make sound by talking and then singing or playing an instrument. Okay, to make you more understand, let's watch the video.
Like if a sound is really loud and kind of unpleasant, like when there's a lot of traffic going by, we sometimes call it noise. And if a sound is made by an instrument like a piano or a ukulele, we call it a note. And we call lots of notes together music. And some words are kind of like the sounds themselves. Like when fireworks go boom, popcorn pops, and bells go ding-a-ling. It doesn't matter what makes a sound though. All sounds are made the same way, through vibrations. When something vibrates, it moves back and forth really fast. So fast, in fact, that our eyes often can't see it moving. But other parts of our body can sense vibrations. And I bet you know what parts those are. That's right, our ears. So how does sound get from, say, a bell to our ears? The air all around us is made of tiny particles, and these particles are what carry sound. We can use marbles to demonstrate the teeny tiny particles that make up the air. Let's see how. If we put a few marbles together so they're touching, then roll another marble so that it crashes into them, the group of marbles will move. That's kind of what happens with sound. When we ring a bell, we cause the metal that makes up the bell to vibrate really fast back and forth. And the vibration of the bell also shakes up the particles that make up the air around it and makes them vibrate. Then those particles run into the air particles next to them, and so on. We can make a kind of musical instrument that will help us to see the vibrations that we make. All we need is an empty can, like a coffee can, and a rubber band that's just big enough to stretch around the can from its top to its bottom. Stretch the rubber band over the top of the coffee can, and ta-da! We have an instrument, one that's kind of like a guitar. Let's pluck the rubber band gently. Does it make a sound? It sure does. And if we look very, very closely, we can see that the rubber band is moving back and forth. When we pull on the rubber band and let it go, we're causing it to vibrate. These vibrations travel into the air, making the air particles move through the air to our ears in a sound wave. If we pull kind of gently, the sound is kind of soft. But if we pull a little harder, the sound gets louder. So whenever you hear a sound, you know that something, somewhere, is vibrating, and those vibrations are traveling through the air and into your ears. So thanks to all of you who asked us how sound works. And make sure to check back every week to learn more science with Squeaks and me, and we'll see you next time.
Now, after you learn the previous video, let's continue to learn more about the sound.
So, sound is the energy that comes from a vibration, and sound cannot be produced without any vibration. Why we cannot always see the vibration that makes sound produced? Yeah, it's because they can happen really fast, sometimes thousands of times each second. If we cannot see vibration, how do we know they are happening? Yeah, we can make vibration visible in many ways. One of the example is we can feel our throat while humming. If you put your hand on your throat and hum, we can feel the vibration of our vocal cords and it makes a sound. There is some sound properties. There are frequency, amplitude, and time period. Frequency is the number of oscillation per second. The unit is hertz, and the frequency means how frequently the particle of a medium vibrate when a wave moves through the medium. And the formula is frequency equals to 1/period. And the second is time period. Period can be said to be the time taken to do something and the time taken by the periodic event to repeat. So it's called period time. The formula is period equals to 1/frequency and the unit of period is second. Okay, and the next is amplitude. Amplitude is the measure of the height of the wave. The amplitude of sound can be defined as the loudness or the amount of maximum displacement of vibrating particle of the medium. Do you know, sound cannot propagate in the absence of medium, and it also belongs to the longitudinal wave, because their propagation form a compression and expansion. When the vibration is stronger, the distance will closer to the source of vibration source and the listener. The distance traveled by the sound per unit time, and it's called sound wave propagation or speed of sound. Yeah, and the formula is V is the speed of sound, S is the distance, and T is the time. So the speed is equals to distance over time, or speed equals to distance time 1/time. And then in case of the sound wave, the distance is equal to wavelength and the frequency is 1/time period. So we can conclude that our formula becomes speed equals to wavelength times frequency, which is the unit of V is meter per second, and then lambda is meter, and frequency is hertz. Let's exercise. When a person shouts and their voice creates a sound wave with frequency of 540 Hz and their voice travels the distance of 154 meters before it is heard by their friend 0.467 seconds later. So the question is, what is the speed of the wave? And then the B is, what is the wavelength of the wave? And the C, what is period of the wave? Yeah. Okay. Let's discuss. For answering the number A, we know that the formula of speed is the distance over the time. Yeah. And the distance are 554 meters and the time is 0.467 seconds. We can put it on the formula and calculate it, and the result is 330 meters per second. Okay, next, to answering the big question, we have already now the wavelength formula is lambda equals to speed over frequency. So we can directly calculate it 330 meters per second over the 540 Hz, and it's equals to 0.611 meter. Okay, remember When we talk about the wavelength, it's related with the matter. The last, for answering the C question, the period of wave, the formula is 1 over frequency. Yeah, so we can answer it directly like 1 over 540 Hz, it is equals to 1.85 times 10 to the power of minus 3 seconds. And then the next is the grouping of sound based on the frequency. It is infrasonic, audiosonic, and ultrasonic. Infrasonic is sound wave whose frequency is below 20 Hz, and the example is dog, cats, and cricket. And then the next is audiosonic. It is sound wave whose frequency is between 20 Hz up to 20,000 Hz, and the example is human. And the third is ultrasonic. Yeah, it is sound wave whose frequency is above 20,000 Hz, and the example is bat and dolphin. Audiosonic also is called audible. It means it can be heard by human, and the infrasonic and ultrasonic is called inaudible sound. It is the human cannot hear the sound of inaudible range. And the next is there are some characteristics of sound. The first is loudness, and then pitch, and the third is quality of sound or timbre. Yeah. The first is loudness. Students can determine the loudness of the sound based on the amplitude of the sound wave. When the amplitude is high, it will produce a sound that is loud and vice versa. So we can conclude that the loudness is proportional to the square of the amplitude, and loudness also is measured in the unit decibel. And the second is pitch. Pitch showing the shallowness or flatness of a sound. Sound can be high or lower, and it's related with frequency. And the example is a woman's voice is different with the man's voice. Yeah, it is because the frequency of a woman's voice is higher. And then the third is quality of sound or timbre. Yeah, the quality of sound is that the property by virtue of which two sounds of the same pitch and loudness produced by the two different musical instruments.
Now, I will show you a simple experiment to demonstrate how different pitch sounds are made. And I have 8 bottles in here, and I wanna use them to make different musical sounds. Are you ready? Let's get started. Yeah, now I have put some water in the bottle, and I will tap on each bottle, and please listen carefully. Yeah, if you listen clearly, you could hear that each musical sound will different, and I will make some song. Can you guess what the song? Why are some of them have pitch higher and lower pitch? Okay, when we tap the bottle using this spoon, it will produce vibration in the bottle, and the vibration will produce some wave. bottle that contains more water, it will produce pure vibration, so the sound will be loud. And while if the bottle is less the water, it will produce more vibration and the sound will be higher. Next, what if I have some musical instruments such as pianica, and then a drum like this, or tantang like this? Yeah. How we can distinguish the loudness and pitch using the musical instrument? Let's consider the example of pitch. Now, I have a pianica and has a musical scale that will make a sound. Okay, when playing a pianica, the key on the right side produces tone that higher pitch than the tone produce the key on the left side. And then in the other example, if I strike a drum, likely we will hear a soft sound. Or like this. But when I strike a drum harder, we will hear a louder sound. Okay. Why? Because in this case, the sound has a larger amplitude and it's determine the loudness of sound. Then, how about timbre? Let's hear part of sound. Okay, and then I have guitar. Did you hear that? So, as the same notes play, the same rhythm and everything, it sounds very different of the tone color. So, it is a timbre or quality of sound. And the important thing to remember is that every instrument has a different way to be played. Another thing is how if the different sound is being combined together. It might sound like this. And then, how about echo? When I shout, "Ah!" Why we do hear the echo? Let me explain briefly what an echo is. Yeah. When I speak or loud in a big empty hall, we hear our sound repeatedly. This is because our sound wave get reflected from the walls of the hall back to us. The reflective that we hear is called an echo. And I will explain more deeply about an echo in the next meeting. Okay, we have learned a lot about sound. Let's review first. So, sound is caused by vibration that travel through the air, and it's also related with the properties, which is frequency, amplitude, and then time period. In the characteristic of sound, there are the first is loudness. It is the distinctions between loud and feeble sound, and the second is pitch. It is distinctions between stillness and flatter sound, and the third is timbre, or quality of sound. It distinguishes one sound from another having same loudness and pitch. And you can do some experiment at your home. Science is fun, right? Remember, to the next material, we are gonna learn about the reflected of sound. Thank you for watching the video. Hopefully you can understand more, and don't forget to exercise the link or barcode in the next slide. See you in the next video.